All right, so we are moving along. We're looking at these kind of problems. I'm hoping that a lot of these are feeling pretty comfortable at this point. We got this kind of problem where we got to divide each part, break it into two fractions, right? Kind of like here. Make it into two fractions, then simplify them, and then integrate that. You got this one where you're going to make that into a -1/2 before you can really do it. This one you're going to need to FOIL it out before you can solve it. And this one you need to distribute before you can solve it. Know your properties of exponents. If you need more work with this, just go back into the book and check it out. But I'm going to skip over this for now. So now we're talking about a particular solution, a differential equation. So a differential equation is another way of writing a derivative, I guess, or it's kind of like integrating. So we have big F prime is equal to e to the x. So I guess if this is the derivative, because this is a prime here, what would big F of x be equal to? So if I antiderive e to the x, I just have e to the x. The antiderivative of e to the x is e to the x, but I had to have a plus c there. So look at that blue equation for a second, and let's just talk about that for a minute. Well, here's the deal. We know that if the x is 0, if we take and we put 0 into this, right? Should be what I'm talking about. If we put 0 into this, we should get, for the whole equation, f of 0 should equal 3. So this whole thing should equal 3. Or you put the 3 here, and put it in this area. So I guess in a sense, we have the following. This whole thing is e to the 0 plus c should equal 3. E to the 0 is 1, so 1 plus c should equal 3. C is equal to 2. And what you need to do is you need to take that c is equal to 2 and put it here, and that is a particular solution. It's a solution with a particular c. And our real answer is pretty simple. F of x is equal to e to the x plus that number we found, which is 2. So all you're doing is plugging in to your antiderivative, and you're finding the actual c and putting it back in. Because if they give you this information right here, if they give you this kind of information, you should be able to do that. So that's that example. And here's another thing that you can kind of think about. Whenever you're solving an antiderivative like this, you're going to want to put the dx over here, so you're kind of like multiplying dx over in a sense. And then you can just antiderive this, and the antiderivative of y is just y. So that's going to antiderive to y. This is going to antiderive to, well, little f becomes big F of x. So if you antiderive that, you get that. The dx could be confusing. We can talk about that more in class, but I'm hoping you have a general idea of it. It's saying what variable to use, basically. So you tried this problem. Take a second. It looks like they gave you a derivative, so find the antiderivative, and then use this in your antiderivative. And then I want you to have what your antiderivative equals, but instead of a c here, I want you to tell me what that's going to be. Okay? So pause, give it a shot, and then I'll show you the answer. Okay, so the antiderivative was 5s squared minus 3s to the 4th plus c. And then you need to simply replace the s's with 3, so you have 5 times 9 minus 3 times, if you put a 3 in, you're going to have, let's see, I think you're going to have 81 here plus c, and that's all going to equal 2, so that whole thing is going to come out as 2. Solve that to find your c, and you should be in pretty good shape. Okay, so I think we were at a point of trying to find c. So we have 2 equals 45 minus, well, 81 times 3, a little bit of work here. I guess 243 actually. So 243 plus c. So I don't know, if we add 243, we have 245 equals 45 plus c. So it looks like c is equal to 200. And what you're trying to do is take that c equals 200 and put it back into that original antiderivative. That's all you need to do. So take that c equals 200, put it here, and you are done. So that means the solution is 5s squared minus 3s to the 4th plus 200. And that is a particular or an exact solution. So a general solution is when you have the plus c. This is your general solution. It's a general answer, but we don't know if it really pertains to this situation. And this is situational. This is an exact or particular solution. So you're solving, they gave you an equation involving a derivative, and you're solving it to get the original, right? And that is really all there is to it. We'll stop there.